now we're just going to fill in a ton of information about this stuff. So I'm going to actually refer to the work I did on the first problem there. If you just look up at the top of your paper, it's not on the screen right now. Whoa, that's a highlighter. Get out of here. Y equals x squared plus 2x. I think it was minus 15. And then for my factored form, I had my x plus 5, x minus 3. So I got that entire box filled in. My x-intercepts are also called my zeros, also called the roots, everybody. Let's just remember that those three words all really, they refer to the same thing on these graphs. The zero of an equation is when your y equals 0. Okay. Or of a function. And your roots, if you think about factors being the roots of numbers, they're also the roots of the equations, so roots make sense in that way as well. I'm just going to put down what I had from the first problem, which is all good. I can do that. It was -5, 0, and 3, 0. So maybe actually, why don't you take some time to fill this in on your own? Fill in as much as you can and get back here. I'm going to do the y-intercept, the vertex, and the axis of symmetry, and then we're going to talk about what that looks like. I'm also going to fill in as many numbers on this table as possible. I am going to include those x-intercepts. So just pause the video for a little bit and come back and let's look at what we found. Now that we're back at it, I just plugged in for my x-intercepts what we found last time. Plugged in my y-intercept. Now, the y-intercept, don't forget that you can see the y-intercept at the end of your standard form all the time. It's always hanging out right there. It's your C term of your standard form at -15. The vertex, also notice that the vertex is always going to be halfway between your x-intercepts. Parabolas are symmetrical. So if you have two y values that are the same, that's going to continue to happen throughout the entire parabola symmetrically down toward the vertex. So the average, the middle point between my -5 and 3, those two, the y-intercept or the x-intercepts are -5 and 3. If I do my average of those, -5 plus 3 divided by 2. Oh, check it out. The x value of my vertex is halfway between my x-intercepts. Radical. I love it. So then if I plug in my -1, oh hey, it all makes sense. I could plug it into my standard form, or I could have just looked at my vertex form. I just want you to see that we can get to this vertex in a lot of different ways. And then the axis of symmetry is always the x value for your vertex. So if I wanted to put that on my graph, that's going to be a vertical line straight through my vertex. Now, I had to go by 2's here because I had to get to a y value of -16. So I went by 2's. And I plugged in what I have so far, my y-intercepts, my x-intercept, or x-intercepts, y-intercept, and vertex. If I want to know where that -3 and the 1 are, I have two options. I could either check out the table on my graphing calculator, or I could just plug these in. Let's just practice that, because for some reason it's still just a pickle to some people. I'm going to plug those into the x value into my standard form, and I want to know what's the y value when my x is -3. That means I'm going to get a 9 minus 6. I'm feeling a 3 there, minus 15. Oh, hey. That's going to get me a -12. And then again, look, these are symmetrical. So if I get my -3, my 1 better be the same. These are the same because they're the same distance away from my vertex. And same for these guys. See, it's all symmetrical. Therefore, my 15 at 0, the 0, negative 15 for my y-intercept, that has to happen at negative 2 as well. Those are symmetrical. And then if I go down to my x value of 1, my x value of negative 3, we also have that. Now this is looking really cute. Super nice. It's a parabola. There we go. Let's just try our next example here.